Good morning everyone. Myself Parvathi K K, Assistant Professor of Department of EC, Vedavyasa Institute of Technology. Today I want to discuss about satellite communication for maritime surveillance. These are the contents. Now let's move on to the introduction. The world's oceans cover more than 70% of the Earth's surface and serve as a vital part of global trade, connecting nations and providing access to essential resources. However, the vastness and complexity of maritime environments pose unique challenges in terms of safety, security, and environmental protection. To address these challenges, satellite communication has emerged as a transformative technology playing a vital role in maritime surveillance. What is meant by satellite communication? A satellite body is a body that moves another body in a mathematically predictable path called an orbit. A communication satellite nothing but a microwave repeater state in a space that is helpful in telecommunications, radio and television along with internet applications. A repeater cycle which increases the strength of the signal receiver and retransmitter, but there is repeater work as a transponder which changes the frequency of band of transmitter signal from the received one. The frequency with which the signal is sent to space is called uplink frequency, while the frequency which is sent by the transponder is downlink frequency. The figure illustrates the concepts clearly. The process of satellite communication begins at the Earth station. Here is an installation is designed to transmit and receive signal from a satellite in orbit around the Earth. The Earth station sends information to satellites in the form of high-powered, high-frequency signals. The satellites receive and retransmit the signals back to the Earth where they are received by the Earth stations in the coverage area of the satellite. Satellite footprint is the area of which receives the signal is useful strength from the satellite applications of satellite communication. The importance of maritime surveillance is safety of vessels and crews and safeguarding piracy and illegal activities, optimizing the shipping routes. And the applications of the satellite communication are radio and TV broadcasting, military application and navigation and voice communication. The advantages of flexibility, broadcasting possibility, user can control the network, each and every corner of the earth covered. The disadvantages are interference and propagation, condition of frequencies. The initial costs such as segment loss and cost is too high. Now let's move on to the importance of maritime surveillance. Maritime surveillance is essential for various reasons, including ensuring the safety of vessels and crews, safeguarding against piracy and illegal activities, protecting the maritime environment and optimizing the shipping routes. Satellite communication has become an indispensable tool in achieving these goals. Now let's move on to the challenges in maritime surveillance. Monitoring the vast expanse of the world's ocean and tracking the movements of countless vessels in real time present considerable challenges. Traditionally, maritime surveillance are heavily relied on shore-based radar and visual observations, limiting effectiveness respectively in remote areas. Furthermore, the sheer volume data generated by vessels necessitates efficient and scalable solutions, providing coverage in remote areas. Managing limited bandwidth. Due to limited number of transponders available on a satellite, the amount of data that can be transmitted is limited by ensuring the durability of equipment. The role of satellites in maritime surveillance. The satellite data can be used for MDA can be generally divided into two categories: data monitoring ship movements and data for observing the maritime environment such as weather and oceanographic conditions. Satellites have revolutionized maritime surveillance by offering a holistic solutions to these solutions. They provide a unique vantage point from space, enabling comprehensive coverage of the world's oceans of various types of satellites including LEO, GEO, MEO. GEO is the synchronous Earth orbit, and satellite is one of which is placed at the altitude of 22,300 miles above the Earth. This orbit synchronized with a sidereal day. The orbit can be inclination and eccentricity. It may not be circular. This orbit can be tilted at the poles of the Earth, but it appears stationary when observed from Earth. The same geosynchronous orbit It is circular and in the plane of equation. It can be used for weather forecasting, satellite, TV, radio, and other types of global communication. MEO is the medium Earth orbit satellite network orbit at the distance of about 8,000 miles from the Earth's surface. The signal transmitted from a MEO satellite travels a shorter distance. This translates to improve the signal strength at a receiving end. This shows that a smaller, more lightweight receiving terminals can be used as a receiving end, and since the signal is traveling a shorter distance from the satellite, there is a less transmission delay. Transmission delay can be defined as the time it takes for a signal to travel up to a satellite and back down to a receiving station. LEO is the low Earth orbit satellites are mainly classified into three categories, namely LEOs, big LEOs, mega LEOs. LEOs, which orbit at a distance of 500 to 1000 miles above the Earth's surface, this relatively short distance reduces the transmission delay to only 0.5 seconds. This further reduces need to sensitive and bulky receiving equipment. Little LEOs operate 0.2 GHz, big LEO operate 2 GHz and above range. Mega LEO operate 20 to 30 GHz range. Benefits of satellite communication in maritime surveillance. Satellite communication offers several advantages in maritime surveillance. Global coverage, real-time data, automatic identification system (ATS), remote sensing. Global coverage satellites ensure that no maritime area remains out of each, guarantee real-time monitoring and communication. Satellite system provide up-to-date information enabling rapid response in emergency and security threat. Automatic identification system of satellites collects the data from the vessels, offering crucial details about their identify and locational speed and course, enhancing safety and security. Remote sensing of satellites involves remote sensing techniques such as radar and optical imaging to monitor sea conditions of detecting oil spills, even track illegal fishing, etc. Now let's move on to the real-world applications. The impact of satellite communication in maritime surveillance is evident in numerous real-world applications. Search and rescue operations are expedited, weather forecasting is improved, and environmental protection is enhanced. In addition, the prevention of piracy and illegal fishing and detection of unauthorized vessel activities are bolstered by satellite system. The future trends are why satellite communication for maritime surveillance has become long way. Challenges remain, including a signal latency, interference, and the cost of maintaining satellite systems. However, the emerging technologies and trends such as advanced sensors, AI, and the use of small satellites promise to further enhance the maritime surveillance capabilities in the future. The security and privacy of the maritime surveillance using the satellite communication, ensuring the security and privacy of the data transmitted via satellites is safeguarding sensitive information and maintaining integrity of maritime surveillance system is called continued concern. Let me conclude my presentation. Satellite communication for maritime surveillance is an indispensable tool in enhancing the safety, security, and environmental protection of our oceans by offering global coverage, real-time data, and remote sensing capabilities. Satellites have transformed the way of monitor and manage the maritime activities. As technology continues to evolve, so too will occur the ability to safeguard vital maritime routes and ecosystems that connect our world. Satellite communication is not just a technological advancement. It is a lifeline towards oceans and those who rely on them. That's the end of my presentation. Thank you.